So next up, we have Deneb Meketa from Pixar Animation Studios. He's a senior software engineer who's been working on keyframe animation in USD. So he's going to do an education session for us. So Deneb, feel free to share your screen and your slides.
The preface I have to give all of you is that this is my first time attending a Metaverse Standards Forum meeting. So I am kind of a GLTF idiot, and I'm sure it will show as I talk. There's nothing in these slides that is really specific to GLTF, although I have sort of like the barest sliver of understanding as to what some of the significant differences will be, and I'll try to hit those, but they won't actually be in the text. All right, so why are we putting animation curves into USD? This is probably the most important piece of it, is that we are concerned, and another piece of bias you'll see in these slides is that we think about USD in two different ways. We think about it as a way of exchanging source information and a way of exchanging pose cache information. The case that really got us started at Pixar was animation interchange among DCCs, programs like Maya and Houdini and Presto, where artists want to have their choice of DCC for the task at hand. They want to freely move among multiple DCCs. And as we talk about it more, it's clear that there is a need that USD can also serve with runtimes in terms of delivering animation splines all the way down to browsers and to runtimes that plug into browsers or operate on their own. So gaming is relevant here, movie making is relevant here, medical imaging, educational imaging, etc. But a way of moving splines around to a whole bunch of different packages. Splines are an editable, smooth data representation. Great for storing camera motion, for animating USD scale, bones and skins, and eventually for as a prerequisite for animating full rigged characters using OpenExec, which is a USD project that has begun but will be going for a while. And of course, splines are just a general purpose pipeline tool. I mean, if you want to move data that changes over time around and you want to do it in a way that minimizes bandwidth, that is one example of where a spline might be useful, but there are dozens of others, of course. Some of you are probably familiar with the fact that USD already has time samples, which are discrete values at times for attributes whose values are not constant. Splines are not quite the same as those. A spline is a curve, a continuous curve, defined by keyframes, also called knots, whereas time samples are values at individual times. Splines tend to be sparse. They don't have to be, but they typically are. Time samples tend to be dense. They don't have to be, but they typically are. Generally, splines are used as a source format, whereas time samples are used as baked values that will go into something like a pose cache or a render. And the lookup speed to get the value at a particular time with a spline requires doing a little bit of math, whereas time samples, there is a highly optimized read that USD will perform for you. I'm sure this will be review for a lot of people, but it's important to talk about what the parts of a spline are, because these are the things that are in the object model that USD anim will represent. My summary is that a spline is an artist-friendly mathematical representation of a value changing continuously over time. Not always continuously, but usually continuously. Components of splines include keyframes, also called knots. These are where you specify the actual value at a particular time. The pieces in between keyframes are segments. This is where interpolation happens. And there are different segment types or interpolation methods. The usual curve for us in Presto is Bezier. You can also, of course, use Hermite, which is similar, but more limited in exchange for being faster to evaluate. There are linear segments, and not illustrated here are held segments, which are just constant. Um, Bezier segments have tangents whose positions and lengths can be specified. And we have looping in splines, where you can see a region that is drawn with a couple of echoes that are drawn more faintly. And this is where you can draw a curve just once and then ask the toolkit to repeat it for you. Values are determined by interpolation, where we're looking up a value at a time in between keyframes, and extrapolation, where we're looking up a value at a time outside all keyframes. We are working with a few different packages that we're trying to integrate. With us, it starts with Presto and Maya. And their splines have slightly different features. And this is where I encounter the warning that a teacher once gave me. Venn diagrams seem like a neat idea, but in practice, they're a real pain. And I'll say why I agree at the end of this, but I had to make a slide. There are some common features. Presto and Maya both have keyframes, Bezier linear and held segments. There are some things that are unique to Presto that are probably not interesting to this group, but suffice it to say that anything that we thought was kind of weird or not ready for prime time or Pixar specific or even anim industry specific, we decided to keep out of USD. For our own use, we'll be emulating it. There are some things that are in Presto and that we will be putting into USD, but that are not going to be familiar from Maya. Dual valued knots allow C0 discontinuities, which are useful for an upcoming case called constraints, but also just as a general purpose spline shaping tool. And we have things called inner loops, where you can repeat segments within the domain of a spline. Maya has some curve bases that are not commonly used, that are probably technically supported under the hood, but they're not easily reachable through the UI. So things like sine curves, and Autodesk has agreed that it's, at least at first, not important to have USD anim support things like that. And then there are some things that are in Maya that will be familiar to Maya users, but not to Presto users. These include Hermite curves, unweighted splines, and extrapolating loops. Actually, I think unweighted splines and Hermites are synonymous in Maya, but I'm not 100% sure. And then here's the reason I shouldn't have used a Venn diagram, because there's actually nothing in the bottom segment of the diagram that's in USD, but in neither of those other two packages. But who knows? Who knows? Maybe somebody on this very call will propose the pink thing that goes in there. And so far, every other DCC, and here again, you see the bias of, toward the DCC end of things that we've had so far. Every other DCC that we have studied so far uses a subset of the spline features in Maya. I'm sure this is one of these things where the devil will be in the details. We'll learn about something that's like, oh, sure, there's this other DCC that has this other feature, and it might well be something we consider putting in USD anim and being compatible with and emulating for other clients. And of course, runtimes have their own, the word DCC here should probably be expanded to every other DCC and or runtime that we've studied. So for example, looking at how things like Unreal Engine represent splines seems to be a subset of Maya spline features, but so far that is a shallow understanding, and we welcome any corrections. The way that splines actually work under the hood, a Bezier spline is an implicit curve. It is a pair of functions, y and x, both as a function of an abstract parameter t that increases continuously along the arc length of the spline. And because it is a parametric curve, it is not mathematically straightforward to solve for y at x, which is the operation we're typically doing at runtime. We have a particular time. We want to know the value at that time. So it requires Newtonian iteration or some other method to arrive at a value of t, and then we just evaluate the straightforward cubic y equals f of t. This is slow from the perspective of as fast as it could possibly be, but has in practice always been fast enough for Presto, our animation DCC. So whether or not that's the case in runtimes is a question we don't propose to answer, because runtimes are not our bread and butter. And this is where Hermites come in. And it seems from a quick scan of the spec for GLTF that animation curves in GLTF are all Hermites. So these are a familiar cubic form where it's straightforward to solve. You're just evaluating a few terms, and the trade-off that you accept for this is that when you are an artist manually making Hermite curves, you do not have the freedom to specify the lengths of your tangents, only their slopes. However, that doesn't mean that everything that ends up as Hermites has to begin as Hermites. You can, of course, start as Beziers and do curve fitting to convert to Hermites. Another important concept in evaluating splines is the piecewise linear interpolation, the approximation. This is, for example, used for drawing splines. If you're writing a DCC or looking at a tool like USD view that is telling you the value of a spline, you have to, at some point, just put pixels on the screen. So rather than solving at every possible point, you pick a sample frequency and you just get linear approximations that are close enough. And then, of course, there's the topic of curve fitting, where you can say, I have a spline that uses some sort of rich math, and I want to reduce it to a series of splines that that use quicker math. So this is, for example, what you do when you start with Beziers and want to convert to Hermites, and you have some level of precision in mind that you want the approximation to be faithful to. And I will say that curve fitting is something we consider outside our wheelhouse, and we're not going to be including in USD Anim, at least at first, mostly because there are so many different ways to do curve fitting, and everybody has their own specialized algorithms that unless somebody wants to contribute something that they think is the absolute standard, then it will remain a client issue to do any curve fitting before putting curves into USD. I do want to mention that USD Anim is not just splines. Splines is certainly the most important and interesting case, but we have a few other categories that for now I'm calling lerp series, quat series, and held series. So the general case of a spline in USD Anim will be called a series. A spline is a kind of series, the most common kind of series. Lerp series just means something that can only be linearly interpolated. Quat series will hold quaternions, which have some things in common with splines, but are also different in some ways. And held series is just something that could also have been time samples, but that is convenient to represent as a series for programmatic reasons or storage reasons. The value types that USD will support in each of those things, splines, only floating point scalars. All types eventually can be packed into a series of some kind. At minimum, everything can be put into a held series. Quaternions get their own special series. But then if you have floating point vectors that vary over time, and that can either be because the value type has multiple components, for example, like a vec3, or because you have an array of smaller values, those can be held in a lerp series, meaning they can be linearly interpolated. And there's a common API for all four. That's sort of a lowest common denominator. The types of segments supported in splines, again, as per the previous diagram, Beziers, Hermites, linears, and helds. Lerp series just gives you linear and held, but unlike time samples, gives you the opportunity to decide which of those behaviors you want. Quaternion series have sort of an eased form, which is like a Bezier, and in fact, in some technical ways is a Bezier, but you don't have control over the tangents. Then linear and held interpolation and held series is exactly what it says. And the common features among all of these things that will be part of the API that they all support, they all have a concept of keyframes. All of them can have dual values, which allow those discontinuities at the knots. All of them will support loops, and all of them will support metadata so that clients can store their own stuff on the splines that they have in USD. Points where the spline library will integrate with USD. The big one is attribute value resolution. And you ask, what is the value of this attribute at this time? If a spline is in the mix, it will be consulted and evaluated. The order of precedence will be that time samples are always the highest priority because those are discrete values, followed by animation, followed by the familiar defaults and fallbacks. Layers compose, meaning that if you have multiple layers that have opinions, we pick the strongest layer by means of all of USD's various composition arcs. We have this concept of sparse overrides, which is that it might be pleasant in some cases to define parts of a time varying values domain in some layers and other parts in others. For now, we are saying not yet, but it sounds interesting. It is a more general problem than just splines. We will, of course, serialize to and from the USDA and USDC formats. And we have a concept called feature reduction, which is the idea that because we are an exchange format, we want all clients to be able to read all splines as long as they support some minimal set of primitives. And yet we don't want every client to have to support every detail. If you recall the Venn diagram, Presto, for example, doesn't want to support everything that Maya supports. Maya won't want to support everything that Presto supports. So the idea is that if there are, that we enumerate the features that splines require. And if there are features that a spline requires that your client doesn't support, you can request a translation into an alternate form that is within your feature set. And the USD view application will be able to have at least a basic visualization of splines over time. Where we are right now is that we have published our proposal, which has enormous levels of detail on all this, and I encourage anyone who's interested to go look at that. We've begun work on the first version, which is, this was originally a Pixar library. We are modifying it, stripping it down, putting open source standards in place on it. We are partnered up with Autodesk, talking to them all the time. They are hot to add USD support to Maya, USD anim support to Maya, and want to do that as early as possible for a variety of import and export workflows. We do not have any firm delivery date. It is probably a good guess that sometime in early 2024, there will be a version that people can begin playing with, even if not final. That's what I got for now, and I am happy to entertain questions.
Really great, look, really great presentation. It sounds like so well researched and pragmatic. I see Leonard already has the first question.
Deneb, I wanted to go back to an early slide. You took the slides down.
Oh, I'm so sorry. Let me put them back.
It was about slide 2, 3 years or 4, I think.
Let's
where
see.
you first laid out the difference between splines and time series.
Sure. Over hasty presenter. Hold on one sec.
Avoid questions. Get rid of the evidence.
You got it. Yes. Okay. We're back.
Okay. Nope. Way at the beginning.
Way at the beginning. All right. So, this one?
No, next one, I think. Yes. Okay, I guess this is where, okay. So in time samples, if you, let's say for convenience, you have a time sample at 1, 2, and 3, and you want to display your current system time is 1.5. How do you get between 1 and 2? Is it linear interpolation? Is it held, or is it something else?
It's either of those two. And which of those is used depends on the data type. So if you have a linearly interpolatable type, like a
Position.
yeah, sure, yeah, like an array of floats, which a position is a good example. Then you will get a linear interpolation. If you have some other type like a string or an int, then you will get held interpolation. It'll just be constant.
So, and with splines, you can do the same thing by explicitly specifying the interpolation. So what is the real difference between time samples and splines? It seems like splines covers everything time samples does.
Yeah, that, this is such a rich topic that I will start by deferring to the proposal, which covers it at a level of depth that I do not have time for in a meeting. But there are 2 sections there. One is called Splines Are Not Time Samples, and the other is called Time Samples Are Not Splines. And it's subtle. And there are definitely cases where either will do. But there are reasons we have decided so far to keep them separate. And that's one of those sort of fuzzy areas where we don't feel confident that we have 100% of the input that we need. So if anybody has pragmatic opinions on those differences, we'd always love to hear it.
I see. So mathematically, they're the same the time samples are a subset, but you may choose time samples for implementation reasons or
Exactly.
performance reasons. Okay, that's fine.
Yeah, and I think performance is likely the biggest one. Again, that we have this highly optimized read, so that if you are talking to a renderer, and the renderer is parallelized or is doing just one frame at a time, it's important that the renderer be able to get all of the data for one frame from a coherent region of memory, and that's what the time sample packing format in the crate format is about.
Okay, great. Thank you.
Other questions? So if I could ask, are there any open source implementations or partial implementations as part of the proposal?
Oh, all of this is open source, and it's just not there yet. So I'm working on the first version now, and again, by 2024, we should be announcing to the community that there is at least some alpha version.
Cool. And then this would be a noob USD question from me. So can the splines, they can target, like what's animatable within USD? Is it everything, like any material parameter and any, transform node, or?
It should be every attribute. And the only question is, sorry, going through all my stupid builds here. The only question is which of the subtypes of what we call a series you will end up with. If you are doing something that's a floating point scalar, then you'll get a spline. If you are doing something that is, for example, a position triple, then you can do it as a lerp series. Although and there are some subtleties here because there are, and this is especially complex for rotations, and this is also something that's dealt with in depth in the proposal, but there are different ways you can pack things and store them. So if, for example, you are representing a position as 3 floating point scalars, then you have 3 splines you can use, which gives you kind of the most flexibility in terms of shaping, but does separate the interpolation into 3 different components, which sometimes is what you want and sometimes isn't. If you pack it instead as like a Vec3D, then you will get a lerp series, which means you get linear interpolation. So converting back and forth between the two, or just choosing one based on your needs, may be important. The usual rule of thumb for us is that we use splines and separate interpolation whenever we're working in source form. And whenever we're talking about a pose cache, a render, interpolation almost doesn't matter. It would only matter for us for things like subsampling between frames.
Patrick, one caveat to put there on what can be animated. We find it very not just useful but necessary to be able to indicate, typically in a schema, some attributes that shall not be animated. So, for instance, for our transformable primitive schema, there's an attribute that describes the operations, like Deneb was just saying, which particular operations are being sequenced together to move the thing. And we absolutely, we wouldn't know what to do if you could have translate and rotate on one frame and on the next frame have just a scale. How would you interpolate that thing? So that attribute is declared uniform, which means that it shall not be animated. So that would be an invalid scene that attempted to animate that attribute.
Thank goodness
Gotcha.
there's Spiff to correct my misstatements. Thank you, Spiff.
Gotcha. Now I'm tracking. Thank you. Other questions? Or here I see Fora. I see you just or Nicholas? I see you just posted a question in chat. Do you want to share it here with the group?
Let's see.
Oh, he doesn't have a microphone.
Do you plan?
Yeah, go ahead.
Do you plan the case step to also change parameters? Should be possible to apply on text. Oh, sure, step. Yes. So this is what this is what Pixar calls held interpolation, and it's stepwise, it's stair step, it's constant. It just means that there is no interpolation, and you just change values exactly at the knots.
Cool. Other questions or comments?
Yeah, Deneb, you mentioned that there's some kind of scheme for saying that you support a subset of all the different possibilities, but if you do that, and then you also, I think you said there's a translation into what you understand, doesn't that then imply that you need to do approximation or conversions from Bezier to Hermite or whatever it is? So you're expecting there will be some set of translations that are in the library itself, or is there just a place where you can put those translations in if you want them?
It should be part of the USD Deneb library, absolutely. I think so far from the list of spline features that we have developed, it looks as though if every client agrees to implement Beziers, we can emulate everything else mathematically perfectly. So for example, Hermites are a subset of Beziers where the tangent lengths are uniform. Something like loops doesn't have to be supported because we can just stamp out copies of the spline as though they were native. There are a few issues with this. The first is that if you perform, and again, this is covered in some depth in the proposal, but if you perform one of these reduction steps where you're saying, you know, my client doesn't support, for example, extrapolating loops, you can end up with a round tripping problem because if you just blindly write back out the entire spline after modifying it, then you will introduce gratuitous changes due to the fact that it was first converted to something else. I think that's not usually a problem in the sense that there are plenty of use cases that don't involve modification at all, that are only read cases. And for those cases that do involve modification, it seems like for the most part, if you're modifying the spline on a given attribute, it's probably okay to accept that the entire spline can at least be rewritten, even if some regions are not different. But of course, the devil will be in the details. There will be cases where you do want to be more careful about that, and as a client, keep track of which regions are actually different. And there is a utility in the library that we're developing called TS that allows you to diff two splines and find the regions over which they are different. So that would be one tool you could use in figuring out how to write back to USD after having modified. There is another interesting question, though, which is, have we hit on a reasonable standard that in order to have all of our reduction algorithms work appropriately, the minimum standard that everyone has to support is Beziers? Because, for example, and again, please correct me if I'm wrong, because I'm so not the person to be asking questions about GLTF, but it looks as though GLTF currently only uses Hermites. So what that would mean is that in general, taking USD and USD animation and converting it to GLTF would mean a curve fitting process that would have to be implemented on the client side, where you take a general Bezier and approximate it with a series of Hermites. Has that answered your question, or gone way too far? Or?
No, this is good. I guess one thing to think carefully about in all of this is that one of the great aspects of USD is that you can throw all kinds of custom data into a file, metadata that maybe nobody understands, load it into an application, change something that application understands, write the result out, and the stuff it didn't understand basically went for a ride. It didn't get altered in the process. And that's a valuable workflow. I mean, for example, in Omniverse, we're combining a wide variety of tools. We may need to go back into the original authoring application to make some kind of modification for things. So if there are gratuitous changes that are potentially lossy that happen by just loading a USD into an application, changing something it understands, and then writing it back out because there was other stuff in there that, oh, okay, this thing had Bézier's that it only understood Hermite or vice versa. That would not be a great outcome. So if you need to do a conversion, it would be nice to somehow be able to mark that conversion in a way that if you did the default write out afterwards, that you would retain the original. I mean, I don't know if maybe that's too much work, but I guess it's a great and desirable property for USD that if I just read something in, and then I have my limitations, and then I write it back out, that it wouldn't be changed gratuitously.
Agreed. I mean, it's a terrific goal, and we are going to start by. I mean, it's an issue we will quickly have in our pipelines because we have some extended members of the Disney family who work in Maya for some parts of their animation pipeline and in Presto for other parts. And there's a need to do an animation handoff. So we will be doing things where we have data going back and forth. And we're just going to try to implement it in whatever way looks reasonable. And we may start with something where the USD core doesn't really have much support for the kind of fine slicing and dicing that you're talking about. And we implement that on the client side. But then if we feel like there's kind of a slam dunk algorithm that we come up with on the client side, there may be every reason to promote that into the open source stuff. It's also the kind of thing where we will count on people to raise these issues and contrib code to put into the core that will do the best job that we can of faithful round trip conversion, because that's one of our goals also. There is another interesting point you raised, which is about metadata. This is also treated to some extent in the proposal. And this is something where we're sort of asking for input because we don't feel like we have enough information to decide yet. One question we have is if there's metadata, the core, of course, won't know what the metadata is. That's the whole idea. It's blind data. It's something that only the client understands, and that the implementation, as you say, just treats as something that goes along for the ride. There are some kinds of, and it's also worth saying that metadata, we imagine in supporting metadata not just on whole attributes as it already is, but on individual knots within a spline. So that, for example, an authoring application can tag a certain knot as having a certain edit behavior. Like every time I move this thing, make sure that its tangents stay where they are, or stay flat, or stay at the same slope, or angle more toward this other thing, or whatever it is. When you edit such a spline, should the core always preserve the metadata that was there in the spirit of do no harm, or should it always delete it in the spirit of maybe this metadata is no longer valid? Or should there in fact be both modes, and should there be some way of signaling to the core, this is a piece of metadata that becomes invalid under the following conditions? And we don't feel like we really know the answer to that yet. And sort of the path of least resistance is that metadata is completely left alone by the core, which means that there may be cases where it's modified outside of the original authoring application and then read back into that application, and the metadata no longer makes sense. Not sure if that's where we'll end up, but that's probably where we'll start.
I mean, that sounds like a reasonable first step. And then if it turns out that you need the additional feature that you're talking about, then that could be added later.
Cool. Well, we still have a few minutes for the official meeting. Other questions? Okay, so Deneb, thank you again. And what we usually do, we end the recording, and then if folks have time and they just want to hang out, we do our quote water cooler. And if you have time and want to hang out, please join us. But once again, I want to thank you very, very much for your presentation. A great work and great example of what we're trying to do here at the forum. Just sharing this knowledge. And thanks to Jess from Pixar for connecting us as well. So
thank you very much.